Hello students, following question is from test series 1, subject signals and system, chapter introduction to signals and system. Question is asked for 1 mark. The question is, if f of t is equal to u of t plus half minus u of t minus half and h of t is equal to e raised to j omega naught t, which is the impulse response of the LTI system, then we need to determine the value of omega naught for which y of t is equal to 0. And options given are: option A is n pi for all n equal to integers, option B is 2n plus 1 times pi by 2 for all n equal to integers, option C is 2n pi for all n equal to integers, and option D is none of this. So we know that for LTI system, y of t is equal to convolution of x of t with h of t. This formula is equal to minus infinity to infinity x of tau times h of t minus tau d tau. So over here we substitute the value of x of t. So we get u of tau plus half minus u of tau minus half times h of t minus tau d tau. So since this part would change the integral from minus half to plus half, and the h of t minus tau would be e raised to j omega naught t minus tau d tau. So since this part t is independent of the integral sign, we can remove this part outside the integral and we will have the integral from minus half to half times e raised to minus j omega naught tau d tau. Solving this, what we would get finally over here is e raised to j omega naught t by omega times 2j sin omega naught by 2. Now if we want y of t to be equal to 0, that is if sin of omega naught by 2 would be equal to 0. So this would be 0 if omega naught by 2 is equal to pi times n, where n is the integer. So what we want is omega naught should be equal to 2 pi n for all n. So please remember, for this question the final answer is option C, that is 2 pi n for all n equal to integers. So whenever we are given such kind of question, we need to know the basic formulas and basic concepts, various signals. Using this we can solve such kind of questions. For this our final answer was option C, that is 2n pi for all n equal to integers. Thank you.